Hey mathematicians, let's do our homework. Another variability question. This one we do want variability, not without variability. So we are looking for multiple correct answers. So for A, how many inches are in 12 feet? Even if you don't know, we could figure it out. We could look at the star chart, we could do the calculations, and there'd only be one correct answer. So you're looking for a situation where you're like, I don't know, it depends. Are we talking about Monday? Are we talking about Friday? Are we talking about last month? Like, give me more information because it could be multiple things. Number 2, a storm brought more than 5 inches of rain to several cities. The chart shows the amounts of rain recorded in each city. Which list represents the orders of cities from least to greatest amount of rain? So since they all start with 5 wholes, your two choices are, you could change all of your fractions to be out of 8s. I see that you already have 3 that are out of 8s. You can find an equivalent fraction of 1/4 is how many 8s and 1/2 is how many 8s. I think that would be the fastest and easiest way to do it. But if you don't like that strategy, you can change all of your fractions to decimals, and then you'll be able to compare those as well. Number 3. Oops, too far. Number 3. We have an equation, which I can tell is multiplicative because the 12 and the x are smushed together with no symbol between them. And we're looking for an option that models that, like that talks about a multiplicative times 12 relationship. What is x? The number of feet in 80 inches. Looking at B, it also says inches to feet. Okay, so if you don't already have this one memorized, there are 12 inches in 1 foot. So if I said, oh, I've got like 3 feet, then I would do 3 times 12 to get the number of inches that was. So I'm guessing that x is the number of feet in something, because then you multiply it times 12 and you get the answer of however many inches that is. And if we isolated x and said, okay, how many feet are we talking about? You can do 80 divided by 12, which doesn't go in perfectly, but you'll get a decimal answer. And you'll figure out how many feet make 80 inches. That's what we're looking for. Number 4. The following chart shows the number of books checked out at the library. Using the information, how many non-fiction books would you predict to be checked out if the total number of books checked out was 240? So we're making a prediction for a larger total than we actually have based on the information that we have. So in order to go total to total, you need to find this total. And then do the part nonfiction to our predicted part nonfiction. Number 5, which statement is true based on the data in the chart? Ooh, I see 2%. I'm going to avoid those. Those involve more work than median and range. So I'm going to look at G and J first and hope I find an answer. The median number of boxes was 32. Let's see. Ooh, this list is not even in least to greatest order, so that's my first thing. 30, 32, 34, 50, 54. Oops. What happened? There we go. It looks like my median is 34, so it's not G. Range is the maximum. 54 minus 30 is 24. The range of the boxes sold these 5 days was 4 boxes. No. Oh, I see how they made that mistake. Look, if they didn't sort their list, it's those 2 subtracted gives you 4. Ugh, darn, we're doing a percent problem. All right, so percent problems mean you need to add up all of the number of boxes, so we have a total that we can scale to be out of 100. And you're either going to choose the Tuesday number, which is 30, or the Friday number, which is 54. Honestly, I might choose 30 just based on that seems like an easier number to simplify, but you're going to have to add them up and find the total and choose one of those days to test and put that number as the part and see if we get an equivalent percent. If we do, great, that's our answer. If we don't, that's the other one. Number 6, a call from a payphone. Ugh, payphones, not a thing you see that very much anymore, but they used to be like phones that were just on the side of the road that you could put quarters into to call before most people had cell phones. It costs $3.25 for a 10-minute call. What is the cost per minute? Ooh, this is a unit rate problem, which means we are dividing. Cost goes first because they said cost per minute, so cost is going inside and minutes going outside. And really, I can do my long division here if I wanted to, but when I divide by 10, all I'm ending up doing is moving my decimal one space over. So I'm going to end up with the answer, oh wait, that would be multiplying by 10, never mind, moving it one space over. We're going to end up with the answer 0.325, which I see. And now we're done with our homework.